Hey everyone, it's another Wednesday and I'm here with another shop update. So let's take a look what I've done in the past week. So on Friday, the door came out from the painting company and I think it looks very nice. Let's take a closer look. So I was able to commission both the sliding door and the legs and other small accessories, and I think it came out nice. There are a few spots where the paint is missing, and there are few spots where my mistakes of the welding are showing up. But all of these places will be hidden from the naked eye, so there is no problem. And these are the legs. There are the flanges which will connect the legs to the floor. Here are the distance pieces which will move the legs further from the wall. And there's the top piece. I also let the company to paint these feet. There is 3 of them, and they act as a door stop, so the door cannot move in this direction. And they will be 2 on the legs and 1 on the floor. And I will fill the inside with some dampener, some cloth or fabric, so the door will not make any noise when they should rattle. So that's the Thursday, and on Friday I started to make other attachments and other flanges and construction things on the top section, so I can hold the motor and the pulleys and the sensor. And the first thing I did is this freewheeling pulley, which will be on the far right side of the door, and this also acts as a tightener or pre-tensioner of the belt. So the belt goes around the pulley, and these overhauls will give me the ability to move this left and right, so I can tighten the belt correctly. And speaking of the belt, this is the belt. It has 3.5 meters, and I hope that is enough. I definitely should buy just a smidge longer. And it's a linear type. That means it is not connected, but it's like a rope. So it has to be fastened somehow and connected together. And that's what this connection plate is for. This is not manufactured by me. This is a product which you can buy, and it is specifically for this type of belt. So these teeth perfectly match the teeth of the belt, and the whole setup will be mounted onto this plate, which will be connected to the sliding door itself. So when the motor will be moving the belt, it will be moving the sliding door. So that's the source of the movement. And since we are talking about the motor, let's take a look on the motor itself, because I was fabricating a flange for it. So this is the motor, and it has different options for mounting into something. It has these 4 holes on this location and at this location. So I picked up this one and fabricated this screwed flange, so I can weld this onto the top section and then mount the motor on it. I opted for these ribs and reinforcements, so it should be rigid in this direction and also in this direction. And this motor has already some pulley. When I bought the motor, the pulley was included, but I wasn't able to find the correct belt, because there's like tens of different belts with different sizes and different teeth shape, and they are for different type of applications. And I wasn't able to find the correct belt, so I had to replace the pulley, and this is the original one, so I still have to replace the pulley for the same which I have in the belt tensioner. And this belt is slightly larger, and that's because of two reasons. One reason is that I want it to be the same as the tensioner, and the other one is that I need to achieve a higher speed than with this smaller. This is like 10 millimeter larger than this one, so the how do you call this, a circumference, is it? Let me check. Circumference, Oxford Dictionary. Circumference, the enclosing boundary of a curved geometric figure, especially a circle. So yeah, it's circumference, and it is a word. So this circumference is about 20% larger than the one on the original pulley, so the movement should be 20% higher as well. Why don't they call it a circumference then? Anyway, so that's why I replaced the pulley. And the other problem with this motor is that I thought from the photos that this gearbox is a worm gear, which is typically, the shape really told me that this could be the worm gear because it is perpendicular, the output shaft is perpendicular to the input shaft, it is displaced like this. So I thought that, okay, that's great, because the worm gear actually blocks the output shaft when the motor is not moving. So it was quite a surprise when I was able to turn the output shaft, and okay, it is probably some kind of bevel gear, because there is a gear ratio. When I'm turning this, it gives me a lot of resistance. That means the input shaft, the motor, is turning at a greater speed than I'm turning this. So that's kind of a problem, because I was relying on the worm gear to act as a lock as well, because the idea is that when the door is without any power, it should be locked. So the worm gear should be able to do this, because the door, there is no constraint about how secure it should be. The door will be used in the internal offices of the company, and there is no way that there will be some big thievery or something like this. So the bevel gear is sort of a problem which I had to solve with a lock which had to be separated from the motor. So I found some electromagnetic locks, and I found this one, and it's a very simple design. There is a coil. When the coil is energized, it sucks in this pin, and it is unlocked, and then it returns to the correct space. This is so-called normally closed, because when it is not energized, the lock is locking the door itself. And the problem with this lock is that it's 24 volt DC 400 milliamps, but it is actually a 12 volt and around 900 milliamps. So this device is the solely thing which has to be powered by 12 volt DC, and that means I have to add the 12 volt power supply into the system. I could replace this with the 24 volt lock. I found some, but these are not as well built as this one. I think that it can handle some roughness if connected or mounted properly, but the 24 volt I found, they were a little more subtle, so I have to work with this one. The other thing I had to try out are the sensors for detecting certain positions of the door. and I opted for an induction type of sensors, and I have one connected over here. And these small things are industrial standard induction sensors, so they can detect a presence of ferrous materials around this bullseye. So if I, for example, touch it with this, you can check that the backlight on the sensor lights up. That means the sensor is detecting the metal. And the detection distance is very small. It's like 2 millimeters, which is okay. And this one is perfect fit for the type of connection, because it is powered by 24 volts DC, and it outputs 24 volts as well, so it can be detected by the control unit. And they will be mounted and detecting this belt carriage thing. So that's why it is this wide, because it will be traveling under these sensors, thus detecting that the carriage is in a certain position. And there will be 4 positions. One of them is the door are fully closed, and then the door are fully opened. And also I need to know that the door are almost open and almost closed. And why is that? I will demonstrate on this model. So this is almost perfect rendition of the sliding door, and yep, they move like this, and the proportions are also very close to the proportions. It won't be that colorful like this one, but it will serve as an example how it works. So if you are moving something with a motor or any other type of actuator, and it is heavy, it's not a good idea to give it a 100% of the power from the start. You need to rise up to the full speed, carry with the full speed, and then when it's almost about to stop the movement, you need to slow down to 0. And the reason why you should do this is that these big shocks in the system are just wearing out the components. For example, if you need to move something heavy, which everything is heavier when it's not moving, and you need to start to move this. So the power consumption is higher. That means the relays which are switching the motors are stressed. The motor is stressed, the belt is stressed, everything which is holding the belt and holding the door is stressed. So that's why I need to start slow, start to rise up to the full speed like this, then travel with the full speed all the way, and then when it's almost about to close the door, turn off the motor and just slow the things down. So I will have one sensor here which will tell me that the door are almost closed, and that's the information which will tell me just start to progressively slow down the movement. And when it goes in the other direction, I will have a sensor over here which will tell me that it's almost opened, and again I have to progressively slow down. So that's why I need these sensors, and they are perfect fit. They are very small, they can detect the movement, and I just need 4 of them and wire them up to the control panel. And the other thing which has to be dealt with, and which gave me a little bit of nightmare, is the presence sensor. Because the automation of the door should work in a way that it's closed, and then the worker comes in, beeps his ID card or her ID card, and when the employee has the access to this area, the door will open, the employee will go in, and the door will stay open until the door frame is cleared. And once the door frame is cleared, the timer will start the countdown. It will be like 5 seconds, and after 5 seconds the door will close. If during the countdown the person goes through the door again, the countdown is reset, and once again it will reach the 5-second interval, the door will close. The door shouldn't even close when there is some dead object between the door frame, like this box. So these are the constraints of the algorithm or the system which needs to be programmed. So all of that led to an investigation how this is done and what type of sensors there are and what is the price and what should I use and what should I not. So I started to look at the PIR sensors, which are mainly used for detecting presence in hallways, so the automatic lights can light up, or they are used in security systems just for detecting the presence of a person, because the IR stands for infrared, which means it detects infrared radiation which is emitted by live objects like human body. So those are like presence sensors, and only for people, so the boxes and stuff will not be detected. So that's something I don't want to use. So I was looking into other ways how to detect a presence, and I was thinking about to use a distance measuring sensors, which are for measuring the actual distance. And I was thinking to mount this on the top of the door and measure the distance down to the floor. And this is like 2 meters, so I was thinking anything less than 2 meters should be detected as an object. So this works. I made a test with a laser distance measuring sensor, which I have over here. And this very small thing is a module with a time of flight sensor, and it can detect up to 2 meters with a resolution of 1 centimeter, and it can give this information like 10 times per second. So it's very good for this type of application. But this is just like a breakout board, a module, so it has to be connected to some low-level microcontroller, for example like Arduino, and then process this information and pass it to the upper control system, which will control the motors and get information from other sensors. But the problem is that this type of detection is also detecting the door itself. So this will tell me like, okay, there's nothing, there's like 200 centimeters to the floor, and then once this starts moving, it will tell me like, okay, there is like 40 centimeters from the sensor, there is something, and then it will tell me it's like 150 centimeters from the sensor. So this kind of false information is something which is very complicated to filter out. And if not properly filtered, it would, oh god, if not properly filtered, it will look like this. There is nothing between the door, so the door will start to close, the sensor will detect them, so they will open and close, open and close. So it will be some kind of a ghosting effect. So it will detect something which isn't exactly there. So this type of detection is something I wanted to do, but it will take me some time to figure this out, how to filter out these things, if another position will be better or something like this. And the other thing I learned is that the measuring angle is very narrow, so I was able to measure only this small section, so anything which will be in this way or this way won't get detected. So I would need to use like 3, maybe 4 of these sensors, and that's when things get complicated. So I was a little bit worried that this is like not out of my league, but should be solved by some proper sensor, which will cost a lot of money. So I was looking into a infrared sensors, and I have this one here. So this is a industrial sensor from Omron, and it is a combination of transmitter and receiver. So the light transmitted from the sensor should bounce off something reflective and received back to the receiver. And if so, the logic will decide that there is no obstacle. But if there is no reflection, for example, if there is my hand which will not reflect the light, the sensor will tell, okay, there is some obstruction between the reflective part and this sensor. And you can see that just using this white glossy piece of metal will allow me to detect there is a reflection and or there is not. The problem with these sensors is that they have a low range. Some of them are only for like few centimeters. Some of them are for like 4 meters or even higher, but those are very pricey. It's like hundreds and hundreds of dollars. They are also susceptible to some stray light from the environment, so the sensitivity has to be set very precisely. The other problem is that the detection angle, the field of view, is very narrow. So mounting this on the floor or at the waist height is not enough. So there should be like multiple of these sensors, and they should be mounted in the door frame. So they should beam horizontally, and the reflective parts should be on the sliding door itself, which shouldn't be a problem. But the problem is that I will need more of these, and the legs are not exactly prepared for this type of sensors. The legs are quite small, and this sensor wouldn't fit anywhere inside of the frame. And yeah, the price of this solution, and that's just out of the budget for this kind of project. You can find these sensors also in the separate type, that there is only the separated transmitter and the receiver. So the transmitter is just like infrared light, and the transmitter is detecting whether something is some light is just receiving on the optics. So you can find this sensor, for example, in industrial machines, where there is an opening in the machine where the operator should reach in and do some job inside of the machine, and this acts as a safety. So when the operator is reaching in while the machine is doing something dangerous, this sensor will shut down the machine so the operator doesn't get hurt. And you can find these sensors also in elevator doors, because if you take a look at the doors, they are actually hollow, so you can look at the mechanism inside, and there is a infrared curtain on left and right side, so it can detect an obstacle at very low heights like dogs and boxes, and it can also detect at like shoulder height if you reach in with your head, and so you don't get decapitated, which I heard is quite bad. So I started looking on the sensors which are actually used on the sliding door, and there is a number of them. There's a lot of companies which make them, and they cost about $100, and they work on the microwave principle, which is a sort of a radar. So it's a motion sensor, so it can detect the changes of the reflections, and they seem to be designed well. So I bought 2 of them today, so I don't have them with me, and I hopefully think that that they will work. Then that's enough with this kind of problem. And I need two of them because I need to monitor the place in front of the door and the behind of the door. So one of them will be facing this area and the other one will be facing this area. And both of these sensors will be wired into the control panel, and the logic will decide on both of these signals. So that should be nice and safe. So that's all from the electronic part of the project. I ordered a lot of cabling, ordered a lot of other stuff which will go into the control panel, and I have, yeah, I can show you. I have a preliminary schematic of the control panel. It looks something vaguely like this. So there is a lot of like input points which will be clamps. Is that correct? I think. All of them will be labeled, all of them will be connected to the sensors and motors and the power supplies and so on. There will be a control unit which I will be talking in the future. There will be a set of power supplies, some relays, some circuit breaker, and that's all. So I ordered a lot of internal stuff for the control panel, and hopefully I will start wiring this like next week. I really have to do this by the end of the next week. The biggest unknown of this project, the sheet metal enclosure at the top of the door. Yes, it's still unknown. I did some drawing of how it should look, how it should be cut, how it should be bent, and it doesn't look that complicated. But outsourcing this to a company would mean that I would have to like be there and see some test cuts and then change the dimensions accordingly, because yeah, I was talking about this the last week. So it would be much easier to do this here by myself, but that means I need some sort of a sheet metal bender of a width about 160 centimeters. So today I was contemplating about building some bender like this. There's a lot of tutorials and it shouldn't be that hard, but I'm quite running out of time. So I will think about this, and yeah, let's see what I will be coming with this. So yes, that's everything for this shop update, and I hope you enjoyed some of the talking, and yeah, see you next week. Bye. Oh, sorry, one more thing. I'm posting a lot of short videos on YouTube, Instagram, and now on TikTok. So if you are into this kind of content, go and subscribe to these platforms and you will get like daily updates on what's going on. And if you are really big fan of this channel, you can support me on Patreon. And otherwise, you can subscribe, like, I don't know, hit the bell. You know the drill. Bye.